Hello friends, so welcome in the episode 5 of STM32 Zero to Hero lecture series. In this video, we will going to write code to blink the LED on STM32 microcontroller. And from this video, we will do hardware programming, and our board will be Nucleo 144. So here you can see the board. It is connected with the laptop, and this is the power cable. This is power LED, right? And here we have onboard LEDs with this board. You can see this one, these three LEDs, and we will write code to control this. Okay, basically. So for that, first of all, we have to create a new project. Okay, so click on File, New Project. Here you have to select the board. Okay, so let us select our board, which is Nucleo 144 board. Here you have to simply type Nucleo 144. This is the type. Okay, and here you have to select the part number. So our board's part number is 76. Let me search it. Yes, this one, 767ZI. Now click on next. Here give the name. Okay, click on next. Finish. So now next it will open the pin configuration. Okay, so you have to select the pins as per our requirement, and this is first experiment on the hardware. So we will simply choose one LED. Okay, and on one LED we will write something. And now meanwhile, let us understand what is HAL. So HAL is the hardware abstraction layer, right? So whatever we will going to see the programming part, some of the things will be generated by this layer, hardware abstraction layer, right? And here this is what we can say the task of the HAL, how it helps in programming simplicity. So to blink LED, you need to enable GPIO clock, configure pin mode, set output configuration speed, right? Add delay between toggling. Everything you have to do by writing some values into register. So left part you can see without HAL you have to write the registers, but with HAL you can see it's like the function name itself is a documenting, and no manual coding required. Just use this function, call it. Okay, and simply you can see a function is HAL GPIO toggle pin. So what this function will do, this function will simply toggle the current value on pin B0. So consider this pin as a wire. Okay, and let us say on wire currently 0 is there, and if I will simply execute this function, so it will invert that 0. So 0 will become 1, and if that the value will be 1, then it will invert it to 0. So using single line of code, it will do all the required thing for us, right? And this is what the advantage of HAL. So where HAL sits, so here you can see we have physical hardware like transistor, logic gate, everything, right? It's basically silicon chip. So inside a microcontroller, if we go in more depth, so this will be the device, this will be the things within the chip. Then above this silicon chip we have some registers, hardware registers. So whatever we just discussed, so to get the required functionality from the hardware or from the chip, we have to load certain value in the hardware registers, right? And to solve this simplicity, to solve the complexity and to add the simplicity, the HAL is above this layer. Okay, so this is what our layer, or you can say HAL's layer is, and some fixed functions will be there that we will just discuss next. And by calling these functions, you know, in behind the scene, it will actually do all this required implementation. It will do all this configuration in backend. So by calling single function, you will have this register level configuration and all. And above this we have application code, which is main code, and above this final, this is the overall project, overall concept. So the layer like concept, then write this code in application. In application we will use HAL library. HAL library will control the registers, and these registers will talk with the physical hardware. Okay, this is what the overall HAL. We will not go in much detail, right? So now we have some default pins. So first of all, you have to clear all. So now this, you can see now nothing is selected. So basically we have to blink the LED, and for that this is the manual. Okay, this is the manual. You can find this from the internet, Nucleo 144, and in this manual many things are given for the board, but our today's task is to blink LED. So let us say we have LED 1. Okay, 3 LEDs are there on board, and one LED 1 is connected with PB0. So our task is to blink this LED. So for that, what I will do, simply I will select the crystal, right? Because in all the microcontroller, crystal frequency should be there. So simply connect crystal ceramic with HSC. Okay, so here you can see 2 pins will be enabled. So basically crystal is given from the onboard component, and then we have to find the PB0. Okay, so let us say PB0 is this is the PB0. So you have to simply click on PB0. Here you can see these all pins are having multiplexed functionality. So same pin can be used as a ADC, as a ETH, as a timer, as a UART, but our goal is GPIO. And again, if you want to read something, you have to set it as an input, but here we will write, okay, because LED is there, and from microcontroller we have to write, so the direction should be output. So this is what the configuration part. Now you have to simply click over here. So you can see all the configuration part is done. Now we will not touch this clock, and we will simply click over here to generate the code. Again, it will generate required code for us. So it's ready to use code available with us, and all the programming related things this HL will generate for us. So core file will be there in core folder. The drivers will be available. Right, so here you can see we have episode 05 LED, go to core, source, and main.c. So this is the fixed program. You can see system clock, GPIO init, everything is there. And if you will see the system clock, so based on our selection, clock is there. In GPIO you can see PB0 reset. So by default this pin is now enabled and set as an output, so we can use it. Everything is there. Our job is to simply write this main function. Now here while one is blank. Okay, so this is simple C program. You can see from void main to HL init, it will initialize the required functionality, system clock, and GPIO. Now here we have to write the code. Now as I told you earlier, some documented functions are there, and for that you can visit this folder, hard drivers. In driver again 2 folders are there, CMSIS and STM32 HL driver. So open HL driver. Now in INC folder you will have the header files .h, and in source we have C file. So for required functions, right, ready to use function, you have to open SRC folder. In SRC you can see we have DMA, we have I2C, we have RCC, right? If you will enable something like ADC, then your ADC driver will be also available here. So let us open the GPIO, and here you can see this is the basic functions available for us to use, right? So whenever I will use that function in my code, basically it will call this definition only. Okay, so here all the functions are given. So my job is to turn on and turn off LED, or you can say blink the LED. Okay, and for that we have toggle pin function. Here is this GPIO toggle pin. Okay, so let us use this function as it is. I'm just copying it, and here you can see here 2 arguments are there. One is GPIO port and GPIO pin. Okay, so let us reuse this function as it is in while one. Okay, and which pin we want to toggle. So here you can see in this initialize part we have this PB0. So let us take this as it is. So you can see in toggle pin we are just giving port number and pin number. That's it, nothing else. So basically it will invert the current state. If current is 0, then it will invert to 1. Current is 1, invert to 0. Then we will simply add one delay. So for HAL, one ready to use function is there, HAL delay. We have to simply call it with 1000. So this 1000 will generate delay of 1 second. Okay, You can consider this is in a millisecond. So now when first time this code will be executed, after init, this while one is like an infinite time this logic will call. So first of all, it will toggle the pin. So your off LED will become on. Then after 1 second delay, again this function will call. So now again your 1 will be 0 and 0 will be 1. And this is how it will continuously call this. So after writing the code, you can see only 2 lines we have added, and both the lines we have copied from the driver only. However, this I have just written, but this is also available in driver. So now simply debug the target. It will check the possible error, and if error is not there, it will simply display over here, right, in this console. So 0 error, 0 warning. Okay, so now just let us load the program on board. So for that, you have to click over here. You have to run configuration, and here you have to select the project. So our project is EP0 LED, and here this EP0, our target project. Okay, so now I'm just going to upload this on the board. Meanwhile, you can see the board also. Okay, now I'm just clicking over run. You can see this LED indicate that program is currently loading, and now it is completely loaded. And now here you can see this LED is start blinking. If you will closely see this PB0, now it is blinking with interval of 12 seconds, right? So we have just added 2 lines, toggle pin and delay, and using these 2, you can see we can have this LED control. So what we did, we write the code, we upload the code on the board, and now you can say you know how to control single bit on microcontroller using programming. So this is what for this episode. In next, we will control multiple LEDs. Thank you.